We gathered a group of at the time year 10 students, mainly from art and product design, with some scientists involved, and we asked them to make a 3D printer using the parts that were printed from a current 3D printer. Pick students that are going to be in for the long haul because it will take a while for them to build it, students that you know you can build a team with, and students that will have something that would be good for them in their future careers as well.
Well, we're currently working on printing our own 3D printer using another 3D printer. While I was counting transistors, very tiny,
Yeah, it's quite precise. You can't really get it wrong. You'd have to wet the end of the soldering tip and then put it onto the soldering bit that you're going to solder for 1 second, and then put the tin and copper wire with the flux in it onto it for another second, take the flux wire off for a second and leave the tip with the soldering on for a second.
They're the main electrics for the printer, obviously, but the part that we're doing is mainly to do with the heat of the tip that releases the plastic that comes out of the 3D printer.
The application is called OpenSCAD, and it's another kind of application. This one, you define a shape mathematically. You don't draw the shape out. You basically use formula and measure and dimensions to define what you want the shape to look like, and then you convert it, you slice it. So you use another utility called slicer. So it's going to take that file, that model, and it's going to generate a load of slices. But it's too big. So I want to make it smaller. So with this I can scale it. And what we can do with this is we can specify certain properties of the object that we want to print. Okay? So we can do things like, say, how fast I want to print it, what temperature I want to use for the plastics. When it fills inside the object, it's only going to be 30% full. So then I have to generate data that the printer will actually understand, and it's called G-code. Okay. Right, so I export it as G-code, which I've done, and now I can load that into this program. So we load the badge in, which will start out. Now what this tells me is a couple of things. It tells me how much filament it needs. So it says it needs 107 millimeters of filament. And it also tells me how long it thinks it will take, 9 minutes, 31 seconds. And it says how big in the 3 dimensions the object will be. Basically get the printer ready by heating the bed and heating the nozzle. And you want it hot enough for a couple of minutes so that plastic will flow properly. It's about 185 to 190 degrees centigrade, okay, that block there, which is why I use tweezers.
To pick it off.
There's a lot of websites that give you an overview of how these things work and the kind of software you can use, and there's a library called Thingiverse. And if you go, Thingiverse is full of thingies. There are hundreds of thousands of thingies. Thingies are things that people have designed, so you can download and print them. Right, so there are aspects of safety you have to be aware of when you use. First of all, there's electricity around, so you want to be careful what you touch there. Secondly, things will move, so when it's moving, you don't want to have your fingers poking around, particularly where there are gear pulleys. there's a lot of torque generated by stepper motors. Right, so it can finish. And the third thing is that extruder is very, very hot. And it does burn if you inadvertently touch it with your finger. And we just basically tell it to burn. And hopefully everything will work. So I check the temperature. On here I can see that the temperature is 179 degrees in the extruder and 64 degrees here on the bed. We want it a little bit warmer. Right, it's now gone up to 180 and 65. So now I'll start the print. There's a button up here, label print. And what it will do is it will test the machine and check that everything's at the right temperature. And when it's happy, it will start printing.
My name's Harry. Today we've been making the model, the frame for the 3D printer. The easy part was like just following the diagrams and everything, but then we had to get everything measured and exact and everything.
Or should we just make it?
Yeah, I think it's worth it because it'll make it accurate.
We're gonna need to mark off what these actually are for.
Are you using steel rule to make sure that's accurate?
Yeah.
Come on, Howard.
This has to be accurate because the whole.
In fact, it's going to be accurate. We've measured these. We just can't. They were 145.25, I believe they were.
Why is it important to have a jig?
So that when we are maintaining it in about a year or so, we don't have to remeasure every single bit, and instead we can just use the jig to see how accurate all is. This is the one that goes on the top. The other two are being made now. I think this is the one that goes on the top.
We put everything around the wrong way and everything, but we can just unscrew it and then put it back together.
Take them off and put them back on again.
Yeah, I guess.
It was quite good because it's quite hands-on. Well, a lot of the time when you get kids or teenagers building things with adults, the adults take control and they do what they want. Whereas this time I felt we actually got to do it all ourselves. I mean, the adults had their input, but more or less we did it, so it felt quite independent.
I found the DT aspect a little challenging because I'd not done it for quite a while before that.
Oh, hang on, I know what the problem is. Yeah, keep away. We need it on kilograms, so. Right, now try it.
There we go, I have numbers.
With one probe and screws in with 3.
It just says one probe.
Yeah, just with one probe.
Oh, that sounds.
You get it right on?
3. Turn it the other way around. 3.
It's worked. It's good for the camera.
So we can work out the cost.
You can work out a cost.
So so if it was half a metre, it would be 17.5, so probably round it up as 20p in material costs. And then 24 minutes at 2p a minute, was it?
24, that makes 48p.
48p.
Right, that gives you your manufacturing cost. Okay.
So 68p.
And then have to be smart.
Yeah, so is was that for a stretcher? Is that what?
And for a stretcher, that bracelet, how much do you think?
Oh, the
it costs in
bracelet.
the shop?
That's
yeah.
How much do you think people die for? How much?
That is a very good question. I think that means 1.
It's definitely past 1. Okay, and then you've got 1, 2, 3. So it's 13 millimetres, okay? After that, you're finding the best lining up between the bottom lines and these lines. The lines on this bit and the lines on there. So tell me where they best match up. Find the exact match.
Okay. We're about 5 and then 1 and 2.
Okay, so each one of those little lines after the 5 are worth 2. So you're telling me it's 2 after that. So 5, 4.
Yeah.
So it's then, what do we say here?
1, 3.
So it's 13 millimetres, 0.54.
Okay.
So 13.54.
Okay.
Yeah, and that is that bit across there. So
Yep.
13 point, what was it?
5, 4.
54. Okay. There is the next measurement on there.
I'm using Google SketchUp to make a Lego block, and you have to draw the rectangle first to do the measurements, and then you have to do the rectangle inside the rectangle to get the bit down the side. I'm using the square tool and the push-pull tool.
What do you need help with?
Everything.
That's not helpful.
In just 13 short weeks, and with the help of David Price, staff from the school in South Hill Park, the students of East Hampstead Park Community School turned a box of components and parts into a fully operational 3D printer, and even mastered some of the key design skills to bring ideas on paper into a 3-dimensional reality.
And by building it, we got to learn how it works, and we've also learned how we can repair the printer. Like the 3D printer can do so much. Like it can print all sorts of different things. Like you can print parts with it, or you can just print pieces of art with it.
So the school have benefited from having the 3D printer already, as students can use it within their projects, both for art and for technology. It's awesome for students to be able to see how the industrial process goes from computer-aided design to computer-aided manufacture.
I learned how the programs work for making and designing the actual things to print off. I learned how they work, and learned how to solder the components onto a motherboard. You need to get a good designer side and patience for the design of the components that you're going to print out to put onto the 3D printer. I think the advantage that the school has a 3D printer now is we can teach more people about it, and it can be hands-on teaching instead, so that they could have that on their CV to say that they know how to use one, because I reckon 3D printers will be very useful in the workplace in the future.